shit.
That's what I'm talking about.
Wait.
Okay, now, from the beginning.
So, yeah, sorry. We were just doing an aside. Well, welcome, everyone. I'm Jules. I know some of you, many of you, but not everyone. I'm the CEO and co-founder of OTOY. And, you know, we've been working with Unity for a good long while now. Our software is integrated in Unity since Unity 2017.1, and we're really well known. I guess that's probably a good thing to start the slides here. I mean, we're really well known for our rendering software in particular, but also our pretty heavy R&D into researching how to democratize GPU rendering. In other words, bringing cinematic quality rendering from films, whether it's digital doubles or capture, all the way down to users on a mobile device, and coming up with all of the ecosystem pieces necessary for that to work. And our software is currently sold primarily to artists that are looking to do visual effects or motion graphics. But last year, we changed things up. I mean, our software had typically been paired with things like Maya or Autodesk architecture stuff. And last year, we partnered with Unity to embed our renderer, our absolute highest quality renderer, inside of Unity itself. And 6.5 million people now have access to Octane for free. And Octane is, you've probably seen renders done with Octane without even knowing that our software was used, but opening of Westworld, Octane for Cinema 4D, Octane for Max and Maya has been used in films, but Octane is really unique. It's not like the traditional CG software that's been around for decades. It runs entirely on a GPU, 2 GPUs, it's double the speed, and it's a mini physics engine. I mean, a lot of graphics, even in films, are huge shortcuts. You calculate occlusion and you mix that in with the lighting, and all Octane does is it just runs literally the laws of physics and light, and you get back a perfect quality, almost a photographic image. And it's very easy to use, and artists love it for that reason. And it was something that probably would have been possible many years ago had the speed been there. But because it wasn't, it really took GPU rendering to make this thing viable. And all the shots that you saw were all done on NVIDIA graphics cards. Many of them were done on just a few in an office. And that's the magic of having Octane on GPUs, is that you're getting this 10-fold, 100-fold, 40-fold increase in not just in rendering speed, but also in density of being able to pack a bunch of these things together. And our goal with the integration in Unity is to give the quality of the graphics that you guys just saw for all those film and television shows into the hands of Unity artists that are starting to see an introduction of cinematic tools inside of Unity. You have Cinemachine, you have Timeline, you have a whole post-processing stack, which is fantastic. And if you add Octane to that, you almost can skip a whole step of having to learn like a really complex 3D tool, because a lot of people know Unity just for making games, and they know enough about lighting and models and 3D geometry to make it work. But when you have Octane in there, you're really fulfilling an important step towards what I think is the future. And I see the 2020s, even though we've obviously spent all this time and work making photorealistic rendering so special and awesome, it's probably going to be commoditized. And you're seeing that trend kick in with the fact that DirectX, as I was just saying before, is supporting ray tracing, and Vulkan supporting ray tracing. And ray tracing is like one piece of the cinematic pipeline that's always been missing from games. The other thing that's very clear is that you will not need the traditional 3D tools to do high-end cinematics that you used to, because tools like Unity are going to be, real-time game engines can drive those cinematics and still give you things that were never really incepted or put into these previous generation of tools, like Autodesk, for example. And the other thing that I see happening is that once you do get into spatial rendering, whether it's VR or holographic displays, the tools themselves will not be mouse and windows and menus. It'll be very intuitive, and tilt brush, both things that are actually allowing you to build things spatially, are much more likely to be the tools of choice. And I don't think it'll even take necessarily to the next decade for these things to kick in. A lot of these pieces are happening right now. And I was actually really happy to see the attention that the NVIDIA and Microsoft RTX ray tracing got, because I think it shows that people are open to the merge of, the merging of games and cinematics happening. And our goal is just to make that happen as quickly as possible with Unity and with this integration. The other thing that's interesting is I think the intuitiveness of how you control and create content is already starting with the fact that ARKit and ARCore give you a camera lens that you can control and do stuff with, and we're experimenting with that as well. And our journey with Octane started really 10 years ago. We were the very, very, very first company to build a GPU path tracer. And we started with images in 2010 and then did animations in a couple years later. And so every 2 years, we've had a major release of Octane. And by the time we do get to next decade, we're going to be tackling holographic displays, light field displays. Those don't exist yet, but they will. And everything that we're doing everything I've been doing, my passion has been about getting to that point and really fulfilling at least the software stack and the ecosystem for something like the Star Trek holodeck. But we're in 2018 right now, and so our release of Octane for this year is Octane 4, and its focus is on real time and also AI. AI was not something that we initially fully expected to pan out the way that it has in our roadmap, but it's been crazy. And so we released Octane 4 a few days ago to users. There's an experimental build. You can download it. It'll be in Unity very, very soon. And we're adding a bunch of things into Unity in addition to Octane 4 that just makes the integration work much better. So being able to take, for example, your existing assets, the things you guys saw from the opening of those Netflix and HBO shows, you can bring those into Unity, and with the importer that we have, you can convert those into Unity meshes and bake them if they're, if you have the ability to rasterize those. And doing this in one click is awesome. So you guys saw the Unity keynote, you guys saw light mapping and baking. It's great to be able to take Octane and deliver that from any of the existing cinematic workflows that are out there. And we've been supporting that experimentally for a few months, but that's going to be something that'll be part of the next release with Octane 4. And converting Octane materials and Unity materials into something very close to each other is also a huge amount of focus and attention in the coming month. The other interesting piece is we want to be able to allow you to ship a Unity game that leverages Octane. Now, this is a very simple Unity game. It's just tanks. But on the left, you're seeing Octane running in real time. And on the right, you're seeing the Unity OpenGL viewport running in the same thing. So what we need to do is we need to deliver a system in Unity that allows you to take those cinematic assets and create games in Unity Editor and then publish them. So with Octane 4, we'll allow you to publish your Unity games with the Octane runtime. And Brigade is actually a subset of Octane that is specifically for games and high-speed rendering. So Octane 4 is more than 2 years of work. It's actually 5 years of development R&D that went into it, and it's a huge release. Our users love it in the 3 days that they've had to play with it. And I have to say that while we were there, we thought that the most exciting thing was the speed, but really the AI features, which you guys will see, were they were revelatory for me as we were getting this build together, and when we launched it, it's awesome. So there's a lot of stuff that's going around this release that's relevant. One of those is that we're changing the entire licensing model around Octane. Up till now, Unity with 1 GPU has been free, and we're adding now 2 GPUs to that tier, and we're also letting you get 12 additional 3D tools for free, like Blender, that can work with Octane and allow you to use this tight integration. And then for subscriptions, for $20 a month, you just get everything. We give you 2 nodes. You have access to all 25 of these tools. And then we've had a lot of requests for enterprise users that want to have 100 or multi-hundred GPU setups. So we're going to be supporting that with enterprise licenses. And the subscriptions are also now inclusive of being able to render not just on the cloud, but on the blockchain. And the tiers basically give you Octane Bench hours. That's how we price these cloud render jobs. And for $20 a month, you can run 20,000 Octane Bench per hour on the network if there's capacity. Extra nodes, $10 a month. And when we announced the pricing, users went crazy because this is a really, really, really inexpensive way to get a high-quality rendering ecosystem that used to cost a fortune. For enterprise licenses, there's a USB key that we're adding, even more capacity on the network, and you'll notice that it says orc/render. The orc is our existing centralized rendering service. Render is the decentralized version. And the only reason why we have any comfort even pushing these kinds of numbers is that we do think we're going to get a lot more capacity with render. And that's been pretty exciting. The free tier is going to have 12 different plugins. Blender, the only one that we're sure besides obviously Unity is Blender right now, but we're looking to add about 10 others. And you can use it for commercial work. It's free. There's no watermark. And while you can actually pay for the commercial licenses by doing render work on our blockchain system, you don't have to do that. So it's genuinely a free, a free product. The new features in Octane 4 are pretty awesome. And the one that we had announced a while back was the integration of Brigade engine. And Brigade was a separate render that we had built 6-7 years ago that was designed not to necessarily deliver Octane quality, but to deliver path tracing that is similar to Octane, but in real time. And this was a test for 2015 that was running on 80 GPUs. Today, this test could run on a, probably on 8 Volta cards. It's about 3,000 Octane bench, and this is before we had any AI tricks and other pieces. So this basically is no tricks, no baking, no ambient occlusion. It's full path tracing, and it's noise-free in real time. But it took a lot of hardware to deliver that. But that's pretty much what Brigade is. And merging that with Octane was always very hard because this was designed for dynamic scenes. Like what you're seeing here is a bullet physics engine driven in real time. And we even experimented with bringing this Brigade technology to very low-end ray tracing hardware. With PowerVR, they unfortunately went out of business. But the test was actually totally viable. And where we are now is we want to merge this speed and the dynamism of Brigade as a game engine with Octane inside of Unity. And so we've done that with Octane 4. It integrates all of Brigade. There's nothing that anybody's ever seen in a Brigade video and loved about it that is now, that isn't inside of Octane today. And the hardest part was to not break Octane and to make it, because we have obviously 10 years of cinematic assets that people want to be able to use, but we did it. And the very first thing you'll notice is in Octane 3, moving a big object like this giant tumbler from the Dark Knight movie is 1 frame a second. In Octane 4, same asset, 60 frames a second. There's no speed hit to moving objects around. So dynamic scene graphs, games, things can all run now without slowing down the render. And that was very hard to do and to still keep Octane's cinematic quality. So now I can, inside of Unity, I can just take any object and I can move it around. It doesn't matter how big it is, doesn't matter how complex it is. Octane was always pretty fast when you moved the camera around, but it was never this fast when you were dynamically moving and changing objects. And no game engine, frankly, through OpenGL or DirectX can load as many assets as we can load into Octane and still give you this kind of dynamism. So this really is a huge breakthrough. Load times are much faster, but for the most part, the game-changing aspect for artists is that when you're inside of Octane and Octane for Unity, you can move objects around, you can see how the light reflects, and it's not just about the camera angle or even the lighting. Now the objects and the dynamism of the scene itself is completely, is also in real time, and it only takes a millisecond to change anything in the scene, and that's huge. One of the things that this opened the door to do, which was something that's not a sure thing, was we can now render in Octane out of core geometry. And previously to my work integrating Octane in Unity, one of the big windmills I was trying to tilt was that you can use Octane and replace any CPU render. But the one thing that we were never able to really deliver on was if a CPU has 128 gigs of system memory and your graphics card only has 8, Octane can only load 8 gigs of geometry. And that was a real hard bottleneck to solve. But we did it in Octane 4. So now you can have 500 gigabytes of scene geometry in system memory, and you can bring it into Octane 4, and it'll still render at 60 frames a second, and you can move things around, and it is awesome. And this is really one of the biggest features that we wanted to nail, because it means that you actually don't have any limits to the scene complexity, and it doesn't affect the dynamism. And we've started to test this. And 2 GPUs also, even when everything is in system memory, it still runs double the speed. And just before the release of Octane 4, just to make sure it worked, we tested it on 8 Volta cards on Amazon with 150 gigs of scene data. And now that it's in our users' hands, we're seeing that it really does work in the real world, which is awesome. There is a speed hit to some degree from having things out of core. So one of the things that we did was we tracked the topology of data in the scene graph. And if it's something that is out of the viewport, it gets cached differently. And so Scene AI is a way that we have, it's a feature we added into Octane so that we could track data in and out of core And as you're actually running a game or playing, playing back an animation, it'll actually pull things in and out of course so that you get the maximum speed. And it's one of 3 AI features that we added in Octane that frankly have been real game changers. The second one is AI lighting. So we started, in fact, both NVIDIA and OTOY at the same exact time announced AI denoising, which is really important, by the way, and is a big feature we're going to get into. But AI lighting is different than that. That basically is applying artificial intelligence inside of the render itself, not in the post-processing layer where you can clean things up, to make sure that the noise that you saw in those earlier, that was the one thing that made that scene not look real, was the grain, right? The grain, getting rid of grain as quickly as possible is really fundamentally important. And one of the hardest things to do when you're sticking to the laws of physics in a render is spotlights and point lights. So AI lighting, which is what you're seeing on the right versus the left, makes an enormous difference. And it's unbiased. It doesn't change or alter the quality of the render. If you let the render finish, they would all look like the one on the right. But when you're trying to get close to real time and you're trying to make all this happen very quickly, for example, with a few hundred samples, being able to go from something like you see on the left to the right makes all the difference. And when you merge that with AI denoising, then you start to see Octane really coming very close to having that full path trace quality you guys saw in those cinematic scenes in real time. And it also is dynamic, so it's not just something that has to be pre-calculated and then leveraged. Like AI lighting is in real time. So this is without it turned on, and this is 8 samples. This is with it turned on. Same 8 samples, same dynamism. And there's still noise, but it's for 8 samples in real time, we're really close to getting a much closer noise-free render. So if we feed that into another layer, the spectral AI denoiser, which looks at all the surfaces, materials in the scene, it's a deep integration. We did domain-specific denoising for glass. We still have more to do. We have volumetrics, we have skin, and all those things. But today, it's good enough to basically to denoise scenes like this with how many 100 samples. Normally, it takes thousands of samples for scenes that are this complicated with all these refractions in glass to be denoised. And our users, confirmed that yes, their scenes that used to take a minute now can be done in a second. And a 1-second render is at this quality has never been really done before. This is what a 1-second render looks like, and this is it running in real time on 2 GPUs. I'm moving the scene around, it's 50 samples, and then when the AI kicks in, it just finishes the render, and it's perfectly clean. And it figures out, it's basically just guessing how the rest of the render will go, but it's really good at it. I mean, we've done tests where we just let it render to, this is 50 samples. The original scene that this was published to the Oculus stereo cube map, it took 3,000 samples, and there was still noise where that light was, that spotlight was. So, we've actually solved a huge problem, and it's in the viewport, and it's on a couple of GPUs. So one more leap of GPU speed and a couple of more layers of optimization, and the denoiser and this speed will be running in real time, and we'll have Unity-powered scene graphs with dynamic optics that don't need to render more than 10 or 20 samples to get to this quality.
What GPU is this running?
This is a Volta GPU. There are 2 Volta GPUs in there. And one of them is running the denoiser at the same time as the render. Sorry, was there a question?
No, he just said holy smokes.
Oh, okay. The other thing that we're adding in, we have a shading system based on Open Shader Language, industry standard cinematic shader, different than OpenGL and HLSL, but it's used in films, and it's used by Pixar and Autodesk, but it's never really been done in real time in a GPU render. So we added that in Octane 3, and in Octane 4, it does even more cool stuff. It can do atmospheric rendering. We have a planet rendering system, so you can also drop in other planets, but people love this stuff. And it's just meant to simplify. You don't have to worry about building Earth and clouds. I mean, you can now basically, atmospheric scattering, space shots, these things are all just taken care of for you. And our roadmap is to just make this kind of stuff easier and easier to the point where you can just be a creative artist and block out your shot, and reality is just rendered for you, whether it's in real time or whether it's in, for offline media or holographic offline linear media. And there's some other features we're adding for deep pixel rendering, which is important for volumetric video and compositing, better skin, and also probably more tools for that merge into the post-processing stack in Unity. Now going forward, we're probably not going to be doing an Octane 5. We're actually going to be speeding things up. We have so much lined up this year that we probably would be at Octane 6 if we kept at this pace. So Octane 2018.1 is going to be released shortly after Octane 4. And we're going to have continuous release cycles after that. And so since we didn't charge for the upgrade between 3 and 4, we're not going to do that for these other versions. The idea is most people will probably end up moving to subscription models or just use the free version, which is fine. And we're doing better integration with Cinema 4D and Houdini. And just, our users request things, we add them 2 months later. That workflow has actually gone really well. And a lot of things went into Octane 4 that were only requested by users just a few months before. And if you guys have ever seen our previous presentations, I talk about how OTOY is focused on these 3 parts of this holographic pipeline: capture, render, and stream. And we're now, and this year really is the first time where I can say, it's not like 3 companies or 3 subdivisions. When you're talking about mixed reality and the things that come from that or flow from that, you're talking really one service. Because when you're in a device that is blending the real world with rendered content and it's shared with the rest of the world, you're capturing, rendering, and streaming at the same time. And the work that we've done with Octane is just in the middle of that. Our other partners and efforts around capture, all of those have been towards really getting this into one step. And so render is the bigger picture umbrella for all of that. And render is, yes, it's the name of our blockchain token, but it's also the network itself, the SDK, the toolchain, the framework, the service. And we are now at the point where we actually have an SDK that you can use to add to the rendering pieces that Octane can do. You can change the way that Octane Brigade work. The SDK itself has to be used by us. We're rebuilding all of Octane in it, and that's a lot of work. Octane was previously just built on CUDA, and Render SDK is a little different than that. So we're starting to move Octane towards that, and by Octane 2019, we'll have the entire stack running on there, and also everything related to light fields, capture, photogrammetry, streaming. All of our work will end up being on this SDK, and you'll be able to publish modules on the blockchain, on the render blockchain, not just render jobs, and then you'll be able to create services that can be built on top of the system we currently have that is really sort of very linear. It does rendering, it delivers a result. In the case of Facebook, photogrammetry work, we can basically take their 24-view camera and spit out a scene file, but those are still very one-dimensional processes. What we want to do is deliver a system where people can build alternative services or mix those together. And to make this work, because we also want to make sure that if we're going to be running rendered jobs on this network, it runs on everything, not just high-end NVIDIA cards, which are great. So we did a crazy thing a couple years ago. We actually tried to get Octane to run on Mac OS, and the Mac does not ship with NVIDIA cards. I'm sure people have realized that. It only ships with AMD or Intel integrated graphics. So we built a CUDA to AMD cross-compiler, and we got it working. And what we found out was that worked on Windows, it did not work on Mac. And Metal is the only way you're going to get anything working on the Mac. So we started thinking about render as having to have these multiple backends. So we can compile, if we port Octane to render, or anything else for that matter, and we have a CUDA backend, then we keep what we have with NVIDIA. We have x86, we have Vulkan, Metal, and we're about 40% of the way doing this with Octane. So that's really cool because that means that once we're done, Octane and anything that's built on render that connects to it will just run on all these different platforms. And with the 40% of the work that we've done already, we've confirmed at least one important thing, which is that Octane and all the things that we're doing now are not running any slower than the original CUDA version. So the Vulkan backend, the Metal backends, in some cases, maybe even be a little bit faster. And this is even on the very same GPU. A 1080 running Vulkan is actually running faster than the CUDA version of the 40% of Octane that we've done so far. And now that we have Vulkan and Metal, we can target not CPUs, but Intel integrated graphics, which are actually faster than CPUs by a wide margin. And so here's Octane Bench, which is our benchmark scenes. The 40% that's done does the info channels, which is the rainbow normal maps you're seeing there, and the ambient occlusion running on Metal. Here it is running on my MacBook. Not super fast, but probably about as fast as an NVIDIA GTX 650. What's wild, though, is that while that Intel integrated graphics chip on that MacBook is decent, we also got it running on an iPad and iPhone with the Metal backend, and this actually works. And the iPad, the 10.5-inch iPad, is faster than my MacBook. So if it only had 8 gigs of GPU memory, the iPad, the 10.5-inch one, the A10, 2 generations back or 1.5 generations back, would be actually a really usable, Octane workstation. And the iPhone's pretty good too. So this is crazy. It also means that, our vision for, let's say, if we were to run render jobs and you could fit this into 4 gigs on the iPad, you could actually have your iPad charging overnight, running render work. From certainly what the common render jobs were done in 2014 on Octane could be done on these devices, but these are still not necessarily the devices Apple would ship at the end of this year. But I think the takeaway from my doing all this work and seeing the results is that I'm not sure what future the MacBook has with when an Apple A11 can beat it, and much less an A12. So it's really interesting to sort of see that play out with ray tracing. And it's also, I think, given the attention that there's been around DirectX ray tracing, and especially how it's designed for high-end Volta cards, right, which is great. Like, it's great to be able to show that you can run this on an iPad and still do real-time ray tracing, and with AI, get this to be something that can work in real time. So one of the reasons why that matters is that I imagine that a lot of mixed reality for the foreseeable future is going to happen on devices like the iPhone and the iPad and AR Core on the Android side. And so I'll talk a little bit about the SDK. The front end for that is GLSL, and you can also program in WebAssembly, which is now a standard way that you can export to the web. But the GPU part of the web is not really well thought through. WebGL is still really old, so one of the reasons why you need something like this to target this. And we want to let people build totally new types of rendering services, not just Octane, but some hybrid variation of these things. All can be done through the blockchain system. And the APIs that you have access not just Brigade and Octane, but also everything we've ever shown related to light fields and streaming and codecs and mixed reality. So, going back to the big picture, now when we're talking about having a capture, render, and stream in one stack, things like our work with Facebook make a lot more sense. We actually can build something that is able to deliver, not just process the jobs and process the camera work, but also then use render to repackage this data and let people build services that can be distributed the way that Facebook wants, deliver tools that can be leveraged across things like not just Unity, but also After Effects and Nuke, which are more traditional video tool sets. And Facebook's been really a great partner, as well as Unity, in terms of really sort of, and everyone's really excited about, I think, about everyone else in this ecosystem, because it does sort of paint the picture towards figuring out what even video, volumetric video in the future is going to look like. It's clearly going to be social. It's not necessarily all going to be on a website or a link. And I think that having Facebook's interest in all the things we've been doing for many years, going back to Carmack, has been a real blessing certainly for us to learn from. Lightstage, which you see here on the left, high-end capture. We're trying to get that to be as cheap as possible on the phone. Again, the render SDK is going to include, now that we can get to 120 frames a second on cameras and in stereo, it'll include pieces that allow phones to start capturing, maybe not full Lightstage quality, but pretty close to it. And if you capture something and you render it into a light field, then you're skipping the ray tracing step, and it still gives you the equivalent of a hologram inside of Unity Editor, which you can then publish. And on an AR-enabled device, you get a stream that is holographic. And these are all just little demos that we've been showing for a while. Last year at Unite in Austin, I showed this, which was much more interesting. And that's inside of Unity in VR. I'm taking two completely different light fields, and I'm just blending them together as if I had a magic wand. And what's interesting about this is that this is really the very first test of how we could take something like light field renders, sort of real-time ray tracing, and bring them together and make that happen without more expensive hardware. And in this case, you guys might see that there's actual reflections between these two light fields. And so the light fields that they've been traditionally thought of from like the Lightro and other things, like those are media files. Those are visual images. These are much closer to seeing data sets that you can actually almost treat like game objects. And bringing those together in mixed reality, basically it was the first step towards, okay, well now if we can capture the world on that iPhone with the render SDK, and if we can do it even with stereo cameras on the back of the iPhone, which is what we're doing here. So that's converting our office into a depth map on the phone. And then the office now is a completely navigable asset on the phone that I can move around in, which gives me my environment, and we can update that in real time. The next piece would be to drop in these assets, whether they're games or they're real time or they're light fields. And this is an example showing, on the phone, this mixed reality rendering stack where we can do glossy reflections on the phone. We can capture the environment, and these pieces are all they all come together in some interesting ways on a mobile device before they do on any other platform. And the stage, I think, for AR and mixed reality beyond the phone, which obviously is in a lot of people's hands already, is in light field displays. And unfortunately, those are not yet extant. I mean, there's a lot of people working on them, but I couldn't wait. So we built a test framework, which you're seeing here. The very first light field video I ever showed in 2014 at SIGGRAPH was me taking a DK2, putting it on my head, and putting the phone next to me and just moving my head, and having the monitor actually kind of give me like a holographic window. And here we are 4 years later, and I'm using the iPhone X with no glasses. And this is why I did this test, to basically put the light field viewer, our stream, on this monitor, which has a Vive tracker on it, and the iPhone does as well. And the only reason I'm holding a phone in my hand in this video is because I'm recording what I'm doing right now. But this is a light field stream, and it was amazing to see that with no glasses, with nothing on my head. It's awesome. And you can see that the iPhone X is tracking me really well, and surprisingly well. Until we tried all this and hooked it all up and actually did an end-to-end test, it wasn't clear to me how well this would work. It works so well, in fact, that just a slight millimeter of movement makes the light field really change. And you do have to close one eye because the stereo effect can only be for one eye. But a true light field portal or a true light field display would actually have none of these problems. And my thinking is that if you build bigger and bigger light field displays, by the way, because there's a tracker on it, I can move the monitor and the light field also moves, right? So it's not just my head, everything is tracked with everything else. And this is kind of the effect you'd have. I mean, if you had a true light field tablet or wall, your head moving, everything would sort of just be holographic. And after spending a lot of time in very lightweight AR glasses, I will tell you that I wouldn't mind having a light field wall, and having that replace windows. And it's viable. And I think the more time that I spend doing tests like these, the more confident I feel that truly, light field in the home, in your office space, these kinds of giant light field surfaces, when they become cheap enough, will probably be more useful than glasses. Glasses will be needed to go outside, and that certainly will always be the case. But I think the case for light field displays is really compelling. And you guys have probably seen some people working on these things. I don't think that these things are a decade or even 5 years out. I think they're much closer to the present than people might realize. We were just talking earlier about our work at MPEG. I think that our goal, beyond just creating the asset pipeline and these tools and terrific partnerships like we have with Unity, is also about being a good steward for open standards. And GLTF is a great open standard, and it does a lot. But what we've ended up having to use between all the different 25 art tools that now can import into Unity is we had to build a package system that encapsulates geometry, open shader language, rectifies all that. And nobody did that work. It was just never done. And so MPEG LA, the cable consortium, took notice of that and asked us to submit this to MPEG-I as a standard. And that work is progressing. I've been in MPEG a year. And my goal is not only to get it as an MPEG standard, but to make it royalty-free, which it should be. Because I was just describing this earlier. I feel that there's, the future of the encumbered codecs and standards are really, it's not going to work in today's world. And HEVC has been very difficult for a lot of vendors to leverage because it's not even clear what the patents and royalties are on that. So making sure that if Urbach, which is the spec, gets passed through MPEG, that it's a type 1 license, which is royalty-free, critically important. And I think the other equally important part of an open system is a decentralized network. And even if you imagine the web being something along those lines, the web has been decimated by the app model, right? I mean, most people experience the internet through Facebook or an app, and also links aren't permanent; they go away. Websites go down. So the blockchain as a way of preserving IP and really sort of preserving the metaverse perfectly, and not having one central authority that can mess with it, that's really compelling. And that's one of the reasons why we started Render. And I think that on the creative level, on the creative aspects of it, I want to see, mixed reality generally should allow mixing of crazy things. And, I have, when we started Render, we got a new advisor on board the company, J.J. Abrams, who are doing some really fun stuff with him. Hopefully that'll, be something we can talk about at some point later. But just being able to sort of take things and bring them together is, creatively and spatially, it's awesome. And we're the very beginning pieces of these, of this sort of revolution, but it has to start with getting the tools, the technology, democratized, inexpensive, and to really think clearly about what's going to be the platform that's going to be in the most users' hands. A lot of the disappointment, I think, with VR is that a few 100,000 units is not enough. The Gear VR was millions. That was great, but I think for mixed reality and XR to take off, you're probably going to see a lot of attention being put onto phones and a lot of work being done around streaming to those phones so that AR can work. But it's all happening. So anyway, that was a deep dive into Unity and Octane 4, and I'm happy to share any other insights or answer questions or just talk about stuff. Thank you.
Life fields.
Yes.
They are, I don't know, I didn't know much about OTOY until I saw what was in the life field stuff. It was
Yeah.
in my mind, and I was just wondering, what's the pathway for actually being able to get that in Unity?
It's really simple. I mean, it's when I was showing the, I can even go back a few slides. It's just baking. It's just instead of baking a light maps, you're just baking to a light field volume, and that can include an animated light field volume. And the way that I described it so that people really understand it simply is that a lot of graphics back before you had 3D GPUs, 3D graphics GPUs were just sprite-based, and sprites were, pre-rendered with transparent things that you can move around, and that's what these are. They're just, you can take any part of the scene graph in Unity. You can obviously, I mean, we want it to work without having to actually bake to light fields, but we're not there yet. And the fact is, even the very high-end NVIDIA ray tracing stuff, there's still baking that was going on. There were still things that were rasterized. So to me, light fields are just taking an object and running a baking job that turns it into what ended up, what you ended up seeing with in Unity Editor. I was just moving that little one square around, but it was doing millions of rays of ray tracing, but it was pre-computed. It was a lookup. So it's basically a holographic sprite. And our goal is that we provide a simple way of doing that in the free version of Unity so people can try this stuff out. And then ultimately, the reason why I'm confident that rendered jobs are going to get a lot of traction is that doing a high-quality light field bake probably should be done on the render network, because that does take more GPUs and more time, and it's to do it really nicely. It's something that even with denoising can leverage dozens or hundreds of GPUs for, especially if it's animated and it's meant to be room scale and you want to walk through it and it looks like the holodeck. Not everything needs to be done at that level. If it's just an object, probably it could be done locally.
And that's available today?
No, because it starts with Octane 4, and we have not turned on even the normal light field baking. So the normal light mapper. So that we're adding those pieces shortly after the release of Octane 4. And the stages of testing this out is that can Octane itself actually just bake light maps for your Unity scene objects? Obviously, if it's coming in from the Urbach pipeline, that's actually pretty simple. And we also didn't want to turn this on before Octane 4 because a lot of the efficiencies we get even on the blockchain or the service, we don't have any load times for scene data, so we're able to do distributed rendering better. But we want to have this out by summer and let people, with Octane 4, shortly after it's integrated in Unity, go from just normal light mapping, if that's even necessary or practical, given that Unity already has great light mapping, to doing light field baking. And what's going to be missing from that is, while that probably will run fine on PC, we want to make sure that that also streams correctly into mobile AR. So that work requires us to do more stuff on the iOS side. But as you can see, there's a lot of effort going into that as well. But PC-based light field streams should be, something that should happen by the summer, and Octane 4 is a big milestone in making that practical. My pleasure. Yes, in the back.
What do you see as the future in terms of holographic displays? Certainly with, a nice HD TV and head tracking, you can get that holographic effect today. But that's only for.
But you have to wear glasses, don't you?
Yes.
That's the thing. Holographic displays, you don't have to wear glasses. Trust me on this. I will go on a limb and say that if you wear nothing on your face and you're looking at a holographic display, it's about as easy as looking out of a window. And there are differences. I mean, a true light field display is not the same as tracking, and I did that test, right? I mean, and I had to close one eye because already stereo is impossible with head tracking and a mono display. I think that people need to see a light field display, and they need to see that experience firsthand to start to understand why that is going to make a big difference. But let me put it this way. I mean, if you lived in your apartment in Manhattan and you're paying for Park Avenue view, and a light field wall gets set up and it's a few $1,000s, and all of a sudden you now have a Park Avenue view and it looks no different than the real thing, the world changes. If you can go visit classes and you have a wall or portalless bidirectional, I mean, the entire world shrinks to a whole other level. And I also feel the comfort of not wearing anything is something that I probably put on glasses more than a lot of people. And I think even at 4 ounces, it's still a lot. So I think ambient computing through light field displays is, it's still very early, but I think there's a lot of value in that.
So I read a story about a light field display that was every pixel was like a little sphere.
Mhm.
So no matter where you stood in the room, you're like, when you look at the pixel, you're seeing like, for each eye, it's already like predicting like the right image to send.
Exactly. That's what a holographic display is. The real world, you have, and all the light rays, and that's what a light field is. It's all the different light rays coming from all directions, focused through your retina. And a light field display emits that, just like the light coming from the window. Even though there's a solid surface, it's a light field coming out of that window. And if you basically swap the window for a light field display, it should look the same.
But your monitor was just a regular monitor.
Oh, my monitor was a cheap, normal monitor. It
You
wasn't.
were just doing head tracking with the camera.
I was doing face tracking with the iPhone, and basically, although I didn't show it in that video, I was closing one eye because you only can do one eye, and I was seeing what the effect was in terms of its speed, its latency. Also, I mean, I don't think anybody had tested, at least I hadn't seen any research, that's why we did it, how fast the iPhone X10, whatever you want to call it, can track your face and send that to a server that's running the light field viewer. But it's really fast, and that was really interesting. I mean, it could mean that if you were to come up with a connected system where you have your phone in one hand and you're using that as sort of a remote, but you're also looking ahead at a tracked giant display, other than the stereo, yes, you could have that same effect there. But yeah, it really is kind of a freedom to not have to wear anything that I don't think people appreciate until they can kind of see how it feels.
How soon are these like spherical, pixel?
We will know this year, because I'll tell you right now. So I'm not a hardware guy. In fact, I really don't want to spend much time in the hardware business. We do the hardware we must when we need to, especially for light stage. But for the most part, there's different people working on them. I like what Light Field Lab is doing. I think those guys are brilliant, and we'll see. I mean, these prototypes need to happen. But there's enough prototypes that are being worked on, and I've seen enough traction that I'm thinking this will be the year where we can start to really get a sense as to how far away they are, not just from like a demo stage, but also from cost and production readiness. And I don't think it'll take until next year to start to get a sense of that.
That's awesome. I mean, I'm concerned that it might look kind of lenticular-ish, for quite a while.
Yeah. It can't be a lenticular display. If it's that, forget it. That's not a light field display.
But like it's gonna,
Yeah.
To have discrete kind of gradations on angles.
Yeah.
But I'm excited about this.
Well, you know why I went on a limb and backed John Carafan's Light Field Lab is because the resolution he's going for, there's not only no screen door effect, there's none of that. I mean, if it gets built at that resolution, then we're good.
That's awesome.
Yeah, it is. It is awesome.
I actually have a question. Do you have any intent or interest, since you use a lot of CUDA already, of implementing some of NVIDIA's RTX technology in your renderer?
Yeah, the thing is, we don't have enough insight into RTX. It's like they did stuff with Microsoft, and it's very focused on rasterization. But yes, I mean, here's the thing: like we actually have a backend now for D3D and Vulkan. So if there's something we can leverage in there, yes. And obviously it's only Volta. So any Octane user that's not on Volta, and if there's some benefit to RTX, we would lose. On the other hand, we're going to get a lot of benefits from Volta, and denoising is much faster. But yeah, I think it's fascinating.
And with the denoising, I'm glad that you guys are doing it both during the rendering as well as the denoising. But are you utilizing any of the tensor cores to do that?
Yes.
Okay.
Oh yeah. That's why the denoising. So in fact, so the denoising is not optimized for the Voltas yet. We just got it working, and it should be 10 times faster. So instead of 1 second to denoise, 1/10 of a second for 1080p.
So it was really impressive to see, like, the AI lighting and the denoising, like you had it, within a second. Or
Yeah.
two.
It's magical. It's awesome.
Given the trajectory of technology, can you predict, like, at one point when it'll be like, will be like, the whole, like, the three parts that capture the render and the streaming will just be like one step. You'll be live streaming light fields.
Well, I mean, I think the first thing you want to probably know is like when do you get that 1 second down to like 1/60th of a second at that quality and on a desktop? And I think that might be the next 18 months. I mean, I would say that that's because we haven't, that AI should be running 10 times faster. So it should already be 10 frames a second, not one to denoise. And secondly, we don't know what, obviously there's going to be more Volta cards coming out. I mean, if the current Volta is not really for games, so if they're Volta assisted DirectX stuff, I mean, we'll see how fast those things go. This laptop has 2 GPUs. I mean, I think that we'll get this year probably or next year to a point where one high-end desktop class device will be able to run this in real time. Now, the denoising and the AI stuff, if you're going down to what we're showing on the iPhone and the iPad, I think that we really have to use more tricks on that. Like I'm not compromising at all on the Octane quality here, but on the iPad, I might. Even the stuff you're showing with relighting was doing a lot more filtering that we normally would do. We didn't do spectral rendering on the iPhone to get it faster. So we probably will be at a point this year where we'll have something compelling to do capture and blended rendering on iOS devices by the end of the year. It could slip, but that's my target, and it won't be perfect, but it'll look really good, and I think people will be much more forgiving on a phone. And similarly, I think within the time frame of the end of this year, middle of next year, we'll have noise-free, path-trace, Octane quality graphics driven by Unity, not just in Unity Editor, but something you can ship as a game, and not worry about the any sort of compromise in quality. That might need a Volta generation graphics, but still, it could look pretty good. And that doesn't mean that we can't support earlier ones, but the AI will just have to be even better. Like we'd have to figure out if the AI can actually get to this quality from just 2 samples instead of 10 or 50. It's possible. I mean, I've seen it do crazier things than that as we keep improving it.
So your denoising looks great on a single frame, but how does it look on a frame stack with something moving through it?
Oh, it looks perfect. So we did it. At Unite Austin. In fact, I didn't even show it at the time because I figured, it was shown last year. We showed we showed a 10-second clip, and even though each frame is denoised individually, there's no flicker, so it looks perfect. Yeah, I can try to find that. I mean, I can, if you want to see it.
So are traditional CPU-based software rendering approaches going away in dinosaur?
I'm sorry, I didn't hear the question.
Are traditional CPU-based software rendering approaches becoming extinct now?
Yeah.
Nice.
I mean, I think they already were. I think the only thing that was holding CPU rendering by a thread was out-of-core memory, which is now a solved problem. So, I mean.
Doesn't have anything to do with it, yeah. That's true.
Sorry. Yeah.
No, I was just saying if you have anything to do with it, CPUs will go by.
Yeah. Well, I mean, I think that you're seeing every CPU renderer have to shift to a GPU strategy. Arnold is showing their GPU optics-based thing in at GTC next week, as is RenderMan. I mean, who's left? There's V-Ray has V-Ray RT. The thing is, the problem is, and I'm on a panel with a lot of these guys actually at NVIDIA, and we're probably going to talk about like the legacy stuff that we all have to move beyond. So this is denoising 10 samples. This is by the old denoiser from 2017. This is 10 samples denoised, 50 samples denoised, which is similar to what you guys are seeing in the room. But this is the old denoiser, so it's not anywhere near the quality. And this, I guess, is 200 samples denoised, and there's no flicker, so it's perfect. Oh, it's great. I mean, AI is so surprising that as we were putting Octane 4 together, because we didn't try merging AI lighting and AI denoising until a week before the launch, and started, because we knew it was they're important to get to blend together, but it's incredible, and we're just getting started. Like this denoiser is going to get better and better. The AI lighting system is going to get better and better, and the main thrust of the Octane 4 launch was just get what we had out there into users' hands so they can start, saving huge amounts of time and rendering things at 50 or 200 samples versus, 1,000 or 20,000, which sometimes you need. And so, this basically is why I wonder whether, when I say, well, maybe you'll need a high-end Volta card to do like high-end rendering, maybe not if the AI stuff is good. I mean, the problem is that the tensor core pieces on the Volta are not on Pascal. So if we are using AI, it's really going to be accelerated a lot on there. But you look at companies like Huawei that are doing, of course, Apple. I mean, everyone's trying to do accelerated AI chipsets and stacks. That would help with rendering. It would help us for sure on lower-end devices.
This is awesome. Thank you so much.
My pleasure. My pleasure. Thank you so much for stopping by. This is great. Any other questions, thoughts?
I have one question.
Sure.
We are working a lot with 360.
Yeah.
And I saw from R&D that you showed on some Unity that you had Facebook 360 volumetric camera, and you could capture
Yes, that was from my last year's presentation, which I think I still have here.
I would like to know how is that progress.
Well, on our side, I mean, we built the cloud service piece that does the processing, and I think, I can't speak for Facebook, they have their own, they have F8, they have their own stuff, but it's great. I mean, we still have a great working relationship with them, and a big part of what we showed at F8, this is the F8 demo, it's Unity, by the way, was about relighting. And I think the one thing I can speak to about the work with Facebook that is public is the 3D posts that are GLTF. That's, you know, we think about why those posts exist and what the device that most people are viewing them on. There's a lot of interesting convergence points there. But we have some new stuff that's related to this. I don't think we can show publicly just yet, or I need to get permission to show stuff, but it's progressing, and I'm very happy with it. So, and as always, working with Facebook's been great. Awesome. All right, everyone, thank you so much. It's a pleasure.